Okay, so we're gonna get it started. We're gonna do a really quick sound check because I have someone, my co-presenter, joining us virtually from Arizona. So, Brad, can you talk and?
All right, yeah. So thank you. Sorry I couldn't be there, but we just haven't opened up our travel restrictions yet. I'll join you virtually this afternoon. But I'm a director of software architecture for Intel's Internet of Things group in Chandler, Arizona. We focus on a lot of edge topics that we'll be digging into some of them here. Just to whet the appetite, we recognize that the edge is going to be an extremely important area of investment for all sorts of opportunities and use cases. And it ties then everything from on-premises embedded to cloud to AI, computer vision, and robotics. So, with that, I'll hand the microphone back over to Jesus, and then we'll get started.
Excellent. Thank you for that, Brad. And welcome, everyone. Yes, my name, again, Jesus Centeno. I'm the Chief of Staff and Innovation Strategy at TIBCO Software. So I work with part of the office of the CTO at TIBCO. And for those of you that are not familiar with TIBCO, we're a software company, 20 plus years in the industry. We work on a lot of data-related themes or subject areas from integration, connectivity, data movement, optimization, analytics, ML, etc., right? So if you read more about TIBCO, we basically package those capabilities in three main pillars: they connect, unify, and predict. So that's a way for you to get that background. So we're going to be talking about edge analytics, right? And when I hear the word edge, there's always a different picture that comes to my mind. Oftentimes, it's this one right here on the screen. I'm sure that something else is coming up in your mind, and that is just simply because edge can, in the end, mean so many different things. Thank you. So, in my mind, there's always lots of components, lots of pieces, right, moving to a specific geographical area, and that geographical area could be as big as the Atlantic Ocean, and this could be contained with a lot of stuff in them, right, moving all over the place, to micro pieces on a production line, right, going through a process and being measured in different ways. And so, whatever you picture it is, think of it in terms of okay, this is not the only definition of edge, right? Edge can mean so many different things. And why is important edge, right? Like why we talk about edge computing versus cloud computing, right? So thinking a way of understanding, the key differences here, right? When you have cloud computing, right, and coming from the edge, you depend on the cloud side to do all the processing, data transformation, filtering, basically the crunching of the data to get any insight out of the data, right? Any analytical value out of the data, in order to respond to events that they are taking place in real time at the edge. So obviously that process, A, takes time, right? B, tends to be costly. And over time, right, it's simply just not efficient, right? Like you don't get that real-time capability to respond to events as they're happening, right? So that's why it's so important, edge computing, especially if your main focus is on IoT, right? Like edge computing is the core that you need, right? So edge computing, just to make sure that we level set here, the understanding, right, is that ability to then bringing that processing capability, those analytical capabilities closer to where the data is, right? The action is taking place, basically. And then being able to respond to the events that are happening at the edge in real time, right? So whether that response ends up being notification, email, alert, halting a process, lining the need for prevention, or whatever else it applies in your world, right? Like that's the basic justification, right, to go for prevention. Now, it was interesting for me, as I was leaving Austin to come here to see something, that totally got my attention as I was about to board the plane. So on the analytics side, right, like analytical companies, just TIBCO, for example, right, like we've been talking about IoT for a number of years, right? And for us, in my case specifically, right, one of my favorite stories is Formula One, and what we do with for example, the Mercedes Petronas team, all the IoT sensors that go in the car, it's over 300 sensors. They measure absolutely everything down to the millisecond. Because in the end, right, like when you like Formula One, right, you know this, like in the end, a millisecond could be the difference between first place and second place, right? Like it's that competitive, right? But it got my attention that now we're not the only company that like talks about this kind of context for brands, right? I saw this sign at the airport as I was leaving, so I had to take a photo. But yeah, the interesting thing here for me is I think Dell now sponsors McLaren, so it's. But the interesting thing here for me is the fact that you know, Edge is really getting a lot of traction, right? Like big players, you know, companies like Dell, you know, Bradley's here from Intel, HP, IBM, right? Like I mean, they're realizing the full potential, right? Or trying to realize the full potential of Edge, and knowing that a lot of enterprises are still trying to basically address Edge computing. So a huge area of opportunity. So typically, right, like when we talk about the edge, we talk about distributed analytics. What does that mean? It really means basically, if you think of your IoT ecosystem, right, like all the devices that will go in that equation, you're going to have edge appliances, right? Like basically, these need to, you know, these components that are going to allow you to analyze the data in real time in response to it, right? So these are devices that they're going to be very close to the data itself. Yep. Oh, closer to. Okay, sure thing. I'll stay right. Okay, perfect. Yeah, sorry about that for people attending the session remotely. As I was saying at the beginning, I think this is a Zoom session within a Zoom session done virtually and in person, like hybrid. So this is as interesting as it gets. But anyways, yeah. So you know, as I mentioned before, right? Like then you're gonna have additionally your cloud platform side, perhaps, right? So this is where still a lot of the data is gonna end up flowing for things like big data analytics, historical trending, machine learning development, you know, the development of models, the training of those models, and being able to understand overall historical trends, right? So. You know, on top of your cloud platform, typically you're going to have all sorts of enterprise applications that you're, I'm sure, very familiar with, right? Like from supply chain planning, resource management, and oftentimes, you know, you may have, you know, a dotted line, right, from even the edge to those enterprise applications to have kind of like that hybrid view on what's the trend versus what's happening down to the second, right? But you know, there's different, you know, kind of swimming lanes, as I like to call it. Now, for the remainder of the presentation, we're going to be focusing on the blue circle on the screen. So, you know, talking about, you know, like the edge specifically, the devices, and that connectivity between devices and things like, you know, IoT gateways, right? And how you deploy then edge analytics capabilities to the edge. That blue circle has been the foundation of actually the collaboration between Intel and TIBCO on edge analytics. And that collaboration is based on three main open source frameworks. So let me go through them really quickly here. The first one is EdgeX Foundry. How many are you familiar with EdgeX? Just out of curiosity. Have you? Yeah, one. Okay, perfect. Yeah, two. Yeah. So EdgeX is a framework from the Linux Foundation, right? So it's basically, think of it as an IoT platform that comes with very powerful type of capabilities, right? It comes with, you know, device connectivity. So if you think of the richness that we were talking about, like IoT scenarios, that connectivity, being able to connect to all sorts of devices and all sorts of taxonomies of data and try to standardize that taxonomy of data to then process it uniformly, it's huge, right? Then it comes also with a messaging bus and device management capabilities. So for us, you know, there's many benefits that we see using the framework as part of the core of the IoT strategy that we have. And, you know, first of all, right, like it's not us only seeing that traction, right? Like we see that traction with other companies as well, where they are basically focusing their efforts or IoT efforts around EdgeX. So it makes it that much easier to then start interacting and start creating new applications and materialize part of that value faster. But in my mind, in blue, I highlight some of my favorite reasons why EdgeX is so powerful for distributed analytics architectures. The interoperability, the compatibility aspects of it, the extensibility of each layer. So in the diagram, as you can see, you have, for example, the device layer versus core services versus exporting services, right? So each one of the layers is highly extensible. And also, the idea of then basically bringing that consistency, that uniform layer for all your IoT application development as well. A second framework that we use, it's called Project Flogo. It's a open source framework, that was created by TIBCO, but it's 100% open source, and it's used for development of lightweight microservices for event-driven applications. So if you think of the nature of IoT data and the need basically to react to events in an automated way, Project Flogo fits perfectly in there, right? Also, the fact that Project Flogo can help you create very lightweight microservices applications that can be then deployed at the edge and consumed very easily, right? So that's another huge factor. In terms of then portability, right? Like you can deploy these Flogo microservices as serverless functions, as containers, or even directly into IoT edge devices. So I think I mentioned some of these points already, but an interesting point, if you're familiar with Golang, Flogo was created from scratch using Golang. And one of the key characteristics, right, is the low memory footprint that it has, especially as you are looking always try to have like fast startups on edge devices. Some of the use cases that we'll be talking about, in the remainder of the presentation, tie directly to kind of plain vanilla use cases that we see with Flogo itself, right? So this idea of having ultralight microservices, being able to then have like an event-driven architecture, leveraging those services, and use these services to have like an end-to-end execution of a business flow, right? So this concept of IoT pipelines that you are probably familiar with, or you have heard about them before, or seen them before in action, that has been a core aspect, right, of the collaboration between TIBCO and Intel. We'll talk a little bit more about in just a second here. All right, so to talk about the third framework, let me pass the ball to Brad, and then he's also going to tell us how then these three frameworks, they come together into what we call something called Project AIR, and how basically we have fostered the collaboration around Project AIR. Brad?
All right, thank you, Jesus. All right, so I'll start with
1 second, Brad. Let me. Okay, yeah, please go. Yeah.
All right. So we'll start with the definition of computer vision. Computer vision is often munged across, well, it's one of those definitions that it might depend on who you are and what you think about it. But generally speaking, we talk about computer vision anytime we're using software or models or any kind of algorithms to interpret information about photos, frames, or videos that are passing through. So I think years ago, if you were in computer vision, you were very familiar with OpenCV and some of the frameworks like that. And then, lately we're getting into a space where we're using algorithms, deep learning, trained models to extract insights about the information in here. The diagram on here is a very popular type of computer vision where we talk about semantic segmentation, where not only do we want to know what's in the photo, we want to know exactly where it is. And here for some form of driving related information, we have one color representing the roadway, one color representing street signs, and another color representing the vehicles, right? So this particular algorithm would output polygons that tell you where these shapes are within a particular frame, so you can take additional information from that. So the problem with computer vision, though, is that not so challenging on the desktop. If you just want to go ahead and download a video and try to make it work, you could probably hack something together with OpenCV or FFmpeg. Not too difficult a way, but ask yourself if you'd be able to, scale that to 1,000 edges that are over 100 miles away each. And you might start to be a little more nervous. And so that's where we start looking at projects like video analytics serving. So video analytics serving is an open source project that comes from one of the teams at Intel. It's a wrapper. It's basically a pipeline manager for GStreamer and FFmpeg pipelines. In the works, we're looking at OpenCV support, so we could have 3 different pipeline definitions. But the whole idea is to abstract away a little bit of the complexity of individual pipeline creations. So you can actually build up a bit of a library of pipelines. We kind of call it a pipeline zoo. And so we will have a set of pipelines ready to go if you just want to do simple object detection, or if you want to do simple, people counting or line crossing, kind of pre-canned use cases that you can just utilize, as well as allowing you to then go ahead, edit some JSON and create additional pipelines. But the idea boils down to, it's a RESTful API that lets you scale up or scale down computer vision pipelines. I've said pipelines a lot, but if you haven't dug into this problem, what a pipeline is encapsulating is the stage-by-stage processing and pre-processing required. So you can't just throw an image into a computer vision algorithm. You typically have to size it for what the algorithm is expecting. You have to migrate or transform the color space that the images are in. And if you're doing this at 30 frames per second off of a video stream, that's a lot of processing. And rather than go build all that code by hand, pipelines allow you to specify that in a stage-by-stage fashion. So change the frames per second, change the frame size, change the color space. And then by the time you invoke the computer vision algorithm, you've already processed all of the required steps. So the diagram below is actually showing a slightly advanced pipeline. It's a double pipeline. Up top, we have a video pipeline, and down below, we have an audio pipeline. And from left to right, we basically import the video from some source, whether it's a file, an IP camera, or a USB webcam. And then once we decode that into its audio and video parts, then we push the different frames to the audio and video path. So the top path is going through and doing object detection, and then overlaying on top of the image what it found. And so the video output there shows you a dog overlaid on top of the video. And then the bottom path is doing an audio analysis and listening for dog barking. So the circled oval on the slide is actually the inference data coming across the text output saying dog barking. So you can combine the two, right, to doubly ensure that you're looking at a dog and that dog is barking. And the whole idea, though, is extracting from that computer image, that image of video, into actionable data that can then be pushed up the pipeline. So, Jesus, if you want to roll forward. Some of the things I've been talking about, though, the challenges of computer vision are sometimes the technology. A lot of times, it's the basic blocking and tackling, deploying 10 cameras to every campus, and doing that across 100 campuses, corporate campuses, hospital campuses, whatever, right? You have to worry about how you install the camera angles. You have to worry about the lighting conditions, changing weather conditions, whether the camera points at the west and gets impacted by sunsets, or faces the east and gets impacted by sunrises. Then you have to find all the cameras. You have to keep the firmware updated. You have to worry about accounts and management, right? And so I often believe that the challenges in computer vision use cases, it's fun to think academically about, could I detect the thing in the frame and detect the dog was barking? But the real challenge is at the edge, we have to deploy these algorithms across the country, around the world. And we have to do that in a repeatable and easily supportable way. Blending the fact that this is an IoT device, a camera has to be discovered and managed, along with the fact that it's a data source. It's producing that stream that has to be analyzed. And so with that, we introduce Project AIR. So this is an open source project that the TIBCO team, and particularly the Chief Technology Officer Office of Innovation, has been pulling together. We call it the Trifecta because we're basically taking 3 open source projects to create a grander open source project. So we take Flogo for its microservices, we take video analytics serving for its abstraction of computer vision pipelines, and we take EdgeX Foundry for its abstraction of IoT devices like cameras. And when we combine them, it allows us to deliver basically no-code data pipeline. So a user can go into a web page, drag and drop a video pipeline or data pipeline from the edge all the way to the cloud, and they can drop in data processing stages along the way. You want your analytics at the edge, drop the video analytics serving at the edge. You want the video analytics at the cloud, drop it at the cloud, and then run it, right? So it's basically a way to abstract away the detail work of all of these data integrations, device integrations, and camera integrations. So this particular screenshot is showing a dashboard of what it can look like when you see the data being sampled below. You see status of different devices. And again, it gives you a way for power users to take control of edge networks and edge deployments without requiring software engineering teams at every step of the way, without requiring someone to go to their IT department to make a change request, just to start exploring a second use case and whatever that additional value added stretch is. So if we want to roll forward, Jesus, the kinds of examples, because it's a blend of Flogo, you get all the connectivity of Flogo. So all the ways that Flogo can interact with enterprise systems, databases, text file watchers, whatever it takes to pull data in or export data or move it. You get that advantage from Flogo, data manageability. It gives us a chance to create triggered pipelines. That event-driven architecture, sneaks through into project there. We get to move that data to wherever it has to go, whether we're feeding those big data lakes up in the cloud or back at the enterprise. Because it is a web-based application, you can create the visualizations you need. You can monitor all the status of everything going on. And then where it starts to get interesting is when you get into the AI modeling. Right? So we can now deploy the AI models as resources so that not only are we deploying the pipelines, we're deploying those models too. So whether you have to create the models and train them yourself, or whether you've sourced them through another project or another company, it just becomes another resource that gets orchestrated down to all of the edges that you're looking at. Right? And then it gives you all sorts of analytics to look at how you're pulling data across your organization. Earlier, Jesus showed a diagram where the edge is on the left, the IoT devices, and the cloud is on the right. This is kind of an overlay of that. The box in purple is the core of Project Air, integrating both EdgeX, video analytics serving, and Flogo to deliver those capabilities. And because it's distributed, as long as a device can run Project Air agent, you can deploy pipelines wherever you can deploy project agents. And it uses container-based architectures. We can support Docker Compose, IBM's Open Horizon as an orchestrator. So quite a few ways that we can push these containers out there behind the scenes based on what the user desires. And so when we look at the value propositions of what we get to achieve when we work together, and this is why Intel and TIBCO are here today together, because we're able to move pretty quickly, pulling together 3 open source projects to create this greater value in Project Air. It gives us the real-time streaming of data with analytics. It gives us machine learning, and gives us a chance to understand the correlative relationships of why something's happening to the data. And at this particular point, we have a small but powerful ISV in Ireland who's using computer vision in a brand new way to understand how cell therapies are maturing inside of the breeder vats where they're growing the cells. And they look now and they see, Project Air can give them immediate impact because they're experts in the models, but they have to deploy their models to various customers and various labs around the world. And they're a model making team. They're not a deployment team, not an infrastructure team. And so they can lean on these 3 projects plus the unification of Project Air to give them the video pipelines at the edge, the data flow pipelines, and the orchestration that allows them just to click deploy and push that new pipeline out to the 10 labs that they have to support for a new version. So they really enjoy that immediate impact that they're going to get out of Project Air. So let's look at the use cases. Later, you're going to see a quick demo of a defect detection use case where we're looking at computer vision to look for defects in there. Along those lines, we have anomaly detection, very popular, of course, predictive maintenance. We have all sorts of robotics process automation challenges coming our way. And then where it really gets fun with computer vision is augmented reality. Right? So I put on my helmet, I'm wearing my augmented reality goggles. When I look at a pump and someone else is watching from behind the scenes, or we have computer vision watching behind the scenes, highlighting the valve that I need to go look at to open or close the valve or check the temperature on a particular pipe. So a lot of fun use cases coming away just from manufacturing, but we're looking at, in use cases in retail, healthcare, a number of verticals that these projects really apply to. And with that, I'll turn the microphone back to Jesus, who will set up for the demo and walk you through it.
Excellent. Thank you, Brad. So, for the demo piece, as Brad mentioned, right, the capabilities that we're working on, they're horizontal in nature, so they can be applied to a number of different use cases, right? It's not just a particular industry or a particular set of use cases, right? So, for this demo specifically is in the context of manufacturing, and it's in the context of error classification, right? It's an error classification application that can detect different type of anomalies that are happening and can do the grouping, right? Like the aggregation of those anomalies. Other very common type of this type of applications, right, is the idea of basically having immediate action taking place, right? Like if you're seeing a pattern happening on the, let's say, the production line, where consistently, right, for the last 10 minutes, a certain type of problems are happening, then you can also hold the process and fix it before it's more expensive or more costly to you have more waste basically on the production line, and then kind of like the redo of that work. So let me get out of PowerPoint here. Okay. And still okay. Yeah, good. We're still sharing here. Zoom is still going on, so let me switch here to the demo itself. So for the demo, basically we're going to be seeing how Project Air does the installation of required components at the edge. It's going to include basically the installation of the adapter that allows us to capture the video from a camera in the production line. And then it's also going to cover how then we feed that video stream into the infrastructure to do the inferencing and then do the error classification, right, and the aggregation of the data. The demo also covers, how you can easily implement different type of business logic into the interface to consume that data as well. All right, so we start here with the Project Air console. As part of the console, you can see basically the containers that you have running at the edge. In order to deploy the components of Air, you need to have at least two containers up and running already at that IoT device or gateway. The agent and the portainer. So in this case, we see that both components are already active. They are set up correctly. So then that is going to allow us to deploy more infrastructure. There is a UI component. This UI can be running on the cloud side or it can be running on premise, right? But through these UI components, then we can basically do everything else from there. So it's really intended to provide a no-code experience to this type of scenarios. Through this first screen, right, you can see the gateways that have been mapped in your environment. In this case, we just have one gateway that maps our home installation, right, like the home gateway. But we're going to go and add more functionality. So through the infrastructure deployer, you can deploy different services to the edge, right? In this case, in the specific example that we're going to see, we're going to be deploying the EdgeX component. We're going to be deploying application services components, Air application services components, and the Intel video analytics processing components. You can customize some of the capabilities of these components or the options on these components on demand. So you can basically address multiple requirements differently. As the components are deployed, then you can see the number of containers on that IoT gateway device increases, right? And they are successfully deployed, they are running. On the interface itself, now you see the gateway, the new gateway being mapped. Now through this gateway, this is basically the entry point where you can map all sorts of devices that you have running at the edge, right? So in a real life scenario, I think as Brad mentioned, right, you may have, thermostats, you have pressure gauges, you have cameras, right? Like you have a lot of different type of IoT sensors or devices going on, and you can map them all through that existing gateway. Now, more importantly is that once you have that gateway identified, you can create pipelines. And as you create the pipelines, those pipelines are going to create containers as well. So in this specific example, we're going to be creating 2 pipelines. And we can see that the pipelines are there executed correctly. The first one, the reconciler, and the second one, the textile pipeline. So the reconciler, basically what it does is that reconciles the events and aggregates the data, while the second one is going to capture the events from devices, is going to invoke the reconciler service, publish the results into a notification, and also into an error data store in the backend as well. Right, so simple pipelines, very drag and drop type of interface. You can use this interface to create new pipelines, validate them, save them, deploy them, undeploy them, etc., etc. Right? So from the console, now we are going to launch the textile simulator. So basically, this simulator, what it does is that it takes this video stream as a feed. The video stream comes from a camera that is in the production line that is basically just doing the inspection on the textile that has been produced. And basically, the model is going to look for a specific type of anomalies, right? So whether it's holes on the textile, stains, color flecks, etc., etc. Right? This is basically unlimited, right? Like this really depends on the type of requirements that you have. So in this case, we're looking for holes. We ingest or we stream the video, right? The application then ingests the video and then is doing the count of the anomalies that it found. In this case, because we're looking just for holes, right? Like you can see that like the 10 events are all the same type of events. But more importantly, you can see how the events are basically traced, right? So you can go back to the image that triggered that particular event, right? So in this case, now we're going to look for all events, right? And we're going to see basically these being updated in real time, right? So thinking in terms of like, your real life scenarios, right? Where you have, any kind of manufacturing process, trying to identify any kind of anomalies, right? And then therefore taking any kind of actions after that anomaly takes place, right? Like, you can see how from just this one console, right? Like in a no code experience, you can do all those things. All right, so let me exit this and come back here to the to some closing thoughts on the presentation. So, well, we talk about this, right? So think of then, Project Air as that like no code platform that is going to allow you to do IoT development, right? Like development of services, development of applications that can be used for a number of different things, right? Another very powerful concept, that we've seen over and over is the sensor fusion concept, right? So, think of, that video feed that has to be analyzed in the context of other readings from other type of IoT devices, right? So this is commonly seen at, for example, in retail, when you have like the self-checkout kiosks, right? Where you imagine you're in the supermarket, right? Like you're going to see, the typical scanner, but in addition, you're going to see a camera. You may see, for example, a scale, right? That is going to measure the weight of the product. You're going to see maybe like an RFID mat also on the station itself. So basically, what's happening there in real time, right? Is all these feeds coming together to determine if there's an anomaly or not. Right? So you may be scanning a gallon of milk, right? And then, that matches the weight of a bottle of wine, but the shape itself is not going to match, right? So if you put the bottle of wine on the car, that should trigger an alert, right? And in that case specifically, it will, as you've seen it many times, right? In supermarkets, that triggers the red bulb on the top, right? And then the manager comes in to see what's kind of going on at the station itself, right? But it's triggering that like human intervention in the process, right? So these are the kind of capabilities that we're talking about here. Now, as far as how to get involved with Project Air, there's different ways, right? One is definitely engaging with industry groups that we're part of. So a great example of that is the Open Retail Reference Architecture Group. The acronym is ORRA. It's kind of like a difficult acronym, but it's the ORRA group. And so basically this group is sponsored by the EdgeX Foundry group, which is part of the Linux Foundation. And in this group, the whole goal of the group, right, is define reference architectures for certain scenarios, right? In this case, specifically for retailers, that they're looking at deploying these edge analytics capabilities, right, in their ecosystems. So we can see here, for example, in this reference diagram, the idea of having using Air to deploy components at the edge, in this case, leveraging another framework that we didn't talk about it today, right, but called Open Horizon, deploy that infrastructure components at the edge, and those components being things like EdgeX components to, for example, the POS scale camera simulator, the application that I was describing before, pipelines, etc., right? Like very similar to the way we saw on the demo itself. But if you wanna become more acquainted with Project Care and the latest on these strategic collaborations that we're working on, joining ORRA, that would be a perfect way to do it. There's a reference architecture document. There's wiki sites. There's a GitHub repository, and there's a scan code there. You can scan it. That will take you to the page where you can join the group. Now, even if you're not in retail, right? Like, everything that you learned here as far as the reference architecture itself, right, applies to many other industries as well. So it's very portable, very, very transferable to other type of scenarios. In the group, we have organizations like, Intel, of course, that is presenting here with us today, right? But HP, IBM, IoTech, right? Like other big names in the industry. A second way to engage is through TIBCO Labs. So that's the group that Brad mentioned before. So on the TIBCO side, Project Care is part of this program called TIBCO Labs, which is an innovation program sponsored by the Office of the CTO. And really, the main goal of the group is to identify areas of innovation and try to bring those ideas right to life, basically, right? Like, so Project Care being a good example of that. It focuses on open source, right? So it's not selling anything really. I mean, it's all open source development, and it's an excellent way of leveraging what has been done already, right? So if you already have in your mind some ideas on how Project Care potentially can help you, right? Like, definitely send us an email and get the conversation started. Now, how many of you participate in hackathons? Just out of curiosity. Yeah? All right. Perfect. Yeah. So TIBCO Labs is having a hackathon, actually, and the main focus of the hackathon will be Project Air. Awesome prizes, right? Like, first prize, $10,000. That pays a nice vacation in the Caribbean for sure for you. So, second prize, $5,000. Third prize, $2,500. There's a couple of other ways there to get some prizes in this competition. The hackathon will start on November 15, and it will go until February 3rd. So first, it will go through an ideation phase where you'll be able to interact with the TIBCO Labs group that I described, to get feedback on your idea, right? Get it to a final stage, right? And then the best ideas will move on to the next stage, right? The hackathon itself from January 24th to January 31st, and the winners will be announced on February 3rd. So awesome way, right? Like, if you want to have like hands-on experience with some financial motivation there to do it, go for it, right? Like, great way to test your ideas on how to leverage Project Care. And a couple of references there. We have a website there that talks about these capabilities on the left-hand side, the computer vision one. There's a solution overview that you can read at your own leisure. There's other sessions like these ones that we've done with Brad and other folks from the Intel side. So feel free to watch those and at your own pace as well. Easy ways to learn more about Project Care. And if you want to check out Project Care itself, there's a GitHub repository there on the bottom right corner that you can look at your own pace. If you want to stay in touch with us, Brad unfortunately couldn't be here on stage, but LinkedIn always works, so that's an easy way. And invite all of you to the Riot demo night happening right after this, actually. So I'll be there on one of the tables. So feel free to stop by, say hi, and we can chat about anything you want.